Hello, welcome back to Cracking the Cryptic. And it's turned really cold in the UK today, so if that's happening where you are, do think about getting yourself some warm winter clothing like this unbelievable hoodie from Cracking the Cryptic. Yeah, it's part of our merch range, which you can look at on the link under the video. We've also got loads of other stuff actually in the links under the video. We've got all our apps and the Sudoku pad. We've got links to our Patreon content where you can watch my solve of the 6x6 Fistamafel Lighthouse example puzzle. And I mean, that was hard enough. Then you can watch, if you haven't already, Simon's live stream of the 9x9 puzzle, which is basically his longest single Sudoku solve ever. And thank you if you joined us for that at the weekend. Now, on Friday, we will go back to streaming a game, Baba Is You. We're going back to that world, moving that little sheep around and seeing if we can remember anything about how it works, which is highly doubtful. If you watched us playing the Obra Dinn, or indeed if you watch our daily videos, you will know the extent of our short and medium term memory. Actually, yeah, that's quite a good point. I'm about to solve or try a puzzle by Listesh, who first came to our notice, feels like a little over a year ago. And I did the first 2 or 3 of the puzzles by him on the channel. And then every time he produced a puzzle, it was amazing. And it seemed Simon was doing it. So we get back to me doing this one. But what that reminds me is yesterday somebody asked, had I ever done a Fistamafel puzzle on the channel? And I sort of thought I hadn't, but somebody provided a link. If you want to see that, you can go to yesterday's video in the comments, and there is a link to me actually solving a Fistamafel puzzle on the channel, which I didn't remember at all. But anyway, let's have a look at this puzzle now. This looks unbelievable. We've obviously had blank grids. We've had puzzles with minimal killer cages and very few clues. We've had lots of puzzles with no digits in the grid, and this is another one. All it has in the grid as actual numbers are 5 killer cage numbers, none of which make their contents certain. It's incredible to me that this is a puzzle, and we'll read the rules and see how it can be, but even they have left me gobsmacked that this is solvable. Normal Sudoku rules apply, so 1 to 9 in every row, column and box. Digits in cages must sum to the total in the top left corner if given. So those 2 digits add up to 7, those 2 digits add up to who knows. Clues outside the grid show the sums of the indicated diagonals, but the numbers for these clues, which you can see are not there. Oh, excuse me. Right, so going through the rules, yes, the sum of this diagonal is, and here it comes, the numbers for these clues are hidden in the cages as 2-digit numbers, reading left to right or downwards. 1 killer cage belongs to exactly 1 little killer clue, that's the arrow clues, and vice versa. So the sum for this arrow is in one of these cages, here, 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 or here. So let's just go through that. The 7 cage, for instance, could be filled with a 1, 6. That makes 7, but that now reads as a 16, which will be one of the outside clues. So maybe this could add up to 16 by using a 2-8 pair there. So 2 plus 8 plus 6 equals 16, and that 16 is given here. Now that's just one example. The 16 could be for this clue, or for that one. They're all possible. Or it might not be 16 there. And I mean, this is exactly my problem with this. There's so much variation in this. I mean, I'm amazed that this can be a logical solve. There's one thermometer as well. The digit on the bulb is less than the digit there. In Listesh's original, this was shown as a greater than sign. But in this situation, that looked awfully like a V, and that might have confused me, let alone you. So anyway, we've got hidden little killers, basically. They're hidden in the cages, and we have to work out what they are, where they fit. Unbelievable. Give it a go if you feel up to it. If you've got the stomach for it, you can check the video time for an idea. And I'm going to start now. Let's get cracking. And I mean, this is one of those times when I say let's get cracking and I have no idea how to get cracking on this. So let's consider the possible fills for this cage, the 5 cage. It could be 1, 4, which would give us a 14. Now, unfortunately, a 14 could fit anywhere in these little killers. But 23, which is the next one up, well, it couldn't be in those 2 cells. The next one is 32, and that's much harder, actually. None of these 3 cell clues can be 32, so could be there. 41 is the other. Maybe we can rule that out. What's the maximum on one of these 5 cells? Well, the maximum is determined by a 9/8 in the 2 cages which have 2 digits in, and that makes 34. And then this could be a 9, and that makes 43. So 41's possible by reducing that to a 7, or reducing these. Okay. So I've no idea what's in that cage, I've no idea what this is, and I've no idea what's on here, actually. But I do have an idea now. Let's colour that purple. Let's colour this one green. And there is something very slightly interesting, given what we just learnt there, about these paths. And that is that this digit is a tens digit in both of these cages. And I think what we've just worked out is that 43 is the absolute maximum in this puzzle for any little killer clue. Therefore, it's the absolute maximum for any of these cages to have as a 2-digit number. So they must all begin with 1, 2, 3, or 4. So we have got somewhere. We've done something. Now, what's interesting about this being a tens digit is that looking at this cage again, you can put in those maxima here, 9 and 8, in those cells. And it's 17 plus 17 is 34. Now, the maximum here is 38 because the maximum in this cell is 4. And the same is true here because the maximum here is 4. So actually, there isn't a diagonal marked in this puzzle that can be more than 38. So we can reduce all of these possibilities by taking the 4 out. 3 is the maximum. And I mean, I'm not saying that takes us very far forward, but the ones with marked digits, sorry, with killer cage clues, at least have a slightly restricted set of possibilities. That actually can't be a 3. 7, 8, or 9 there. But now what? So this cage is either 15 or 24. But I mean, 24 couldn't be there. And 24 couldn't be there. Because they had 9, 8, 7 aren't possible. But it could be here, and that could be 24 as well. Oh, 9, 8, by the way. Sorry, I shouldn't just leave these as saying 9, 8. Because that's just a maximum. It's not what is on this clue at all. But these markings are right so far. I just need to know how that possibly helps. Suppose these are the only clues that can be more than 24. So only 2 of these digits can be 3s. Doesn't seem to do anything. 17, 34, 36 would be the maximum up here. Maybe we need to consider these 5 cells together. That's 2 little killers. So the most they could add up to is 35, which would be a 1. Oh, the least this can be is, oh, I see, right. The least this can be, the minimum total for this little killer is not determined by the numbers you can put in these cells. It's determined by the numbers you can put in a cage, because the absolute minimum you could put in a cage is 1 and then 2. So this has to add up to at least 12. This does 2. Oh, this has to add up to at least 12, and there's only one way to do that. Oh, that is brilliant. That is blinking brilliant. That's a work of genius. Right, so we get digits. The maximum, so what I'm saying is this little killer clue has to be in a cage somewhere. The minimum 2-digit value that can go in a cage is a 1 in the first digit and a 2 in the second. It's 12. Well, the most you can put in this one, now that we've got this down to 1, 2, or 3, thanks to this work, is a 9 and a 3, and that is 12. So one of those cages must be 12. We get a 7 here as a result of the cage. This can't be 24 now. I'm not sure if that helps. Oh no, now we know there is a 37 diagonal. And it's got to be either green or purple because the others are too small. Oh, and it can't be green because I think I said a moment ago the maximum value here is 36 because that can't be 3. So it's maxing out purple, and this 37 is for the purple diagonal. So let's colour it purple as well. This has to be a 3. And then this cage relates to this diagonal. That's fantastic because again it begins with a 3. It can't be 37 because this can't get that high. Let's colour this cage green. We're using a fair amount of overlapping colours, but green matches to the green diagonal. Purple cage matches to the purple diagonal. That's how I'm going to try and keep track of the numbers. So this has to be at least 31. This cell can't be more than 7. So what would the maxima be? 7, 9, and 8 there. This would add up to 24, 33, 35. So this can go up to 35. But that's 4 degrees of freedom down to 31. So this could be a 3. That's annoying for a reason I'll explain in a moment. I'm putting 4 degrees of freedom into all of those. This doesn't change, but I was looking at 3s suddenly. Where does 3 go in row 8? Well, it's got to be in one of these 2 cells, and I nearly had it ruled out of there, but not quite. So 3 is in one of those 2. Oh, this can't be 3 anymore, nor can that, and that limits. They're both in cages with values in the corner, so ooh, come on, what does that do? Oh, Zippo, it does nothing. Now what? So we've got to try and limit this a bit, haven't we? Oh, hang on, yes, we said there are only 2 possible little killers that can be 30-something, and we've got both of those 30-somethings. So these cages cannot begin with a 3, and that restricts this one a bit further. This is now 28 or 19. This is 23 or 14 in terms of the clues. This is 24 or 15. They're all a bit different. Where can a 20 little killer clue or more? Oh, everywhere. No, this can't be 20 because that's a maximum 2. In fact, they couldn't even be 9, 8. So 18's the maximum there. This can be. This could be 23 as far as I can see as a max. Oh, look, I've done this digit. I didn't even realise the 9 looking at that fixes it. Because I was looking across here. That can be a 9 though, that could be 7, that could be 8, so this could be 24. Now this has to begin with a 1. Oh, it can't even have a 9. Maximum here is 15. And that just means that one of these cages is 15 or less. Well, it can't be that one, but it could be that one, that one, that one, that one, or that one. Okay, that's not very helpful. What about this? It's not really. Oh, okay, it can barely be 20 something, but it can be 21 with an 8 there and a 6 there. That's the only way it can get up to a 20 something total. I wonder if these positions are all going to get limited to 1 each, because that would all fit together in the grid. You'd get a 1 here and 1, no, not there. No, hang on, you wouldn't get a 1 there. You'd get a 1 in one of those. I don't know, you'd get a 1 there and a 1 in one of those. That's not all that interesting. Some of them might be 20 something, I suppose. How am I going to work it out? Now maybe let's look at the degrees of freedom up here. Ah, yes, if this was 24, that can't be 24 because that's a maximum 6. That can't be 24. This can't be 24. This is the only one that could be 24. If that was 24, we'd have 9, 7, 8. I don't know. That's possible, isn't it? Oh, I don't see why not. I'm going to have to find something else. Oh, okay. 9 is limited to those two cells in row 7. That forms a sort of skewed X-wing there. So 9 goes in one of those two in column 7, because the 9s in columns 8 and 9 have been used up in those cells. That's not very useful. Wow, I don't know what I'm looking at here. I don't know what I'm meant to be finding. Now this has to be at least 12. Ah, that's slightly interesting. Maybe. I don't know. Not really. Can't be 9, 3. So 8, 4, 7, 6, or anything bigger than that. That's just too much freedom to do that. How on earth do we keep limiting this stuff? So the max here, 8 and 9, 17, and 2, 19, and 7 makes 26, and 9 makes 35. Can we limit that further? I suppose, okay, here's one thing. For this not to be a 1 and reduce the total by 1, it has to be 24 there. That makes that a 9, and that a 7, and that an 8. This being a 7 here means that can't be a 7, and that does reduce this by 1, so it can't be 35 anymore, because either that is lower or that is lower. But that is a slightly complex chain to even get that tiny bit of information. Okay, if this was a 3, let's try and establish that this is where 3 is, which is what I'm prepared to bet. If that was a 3, these would have to be max. 2 there, 9 and 8 there. That 2 would make this 24, so we'd get that 978. Oh, but if this was a 3, this comes down to 31, doesn't it? Does that help? If that's a 3, this is 31 immediately, and that's 24. I don't see what that's doing for me. I must be just missing some Sudoku bit or something. Sorry, I'm not seeing whatever it is I need to be seeing at this point. Let me just take a step back, have a deep breath and a bit of a think. This could be 21, or it begins with a 1. This definitely begins with a 1. This could get to 24. And this could get as high as 23. This definitely begins with a 1. I just don't know what that means for me. Let's have another look at 24 here, because this is the least likely scenario, I think. 24 there needs 978 over here. Oh, what happens to that if this is 978? This is impossible. The most it can be is 11, which is not a legal sum in one of these cages. So that's not 24. Simple enough if you see it, which I didn't. That's 15. Now, I don't know. That could be even here, but it could be in any of the 3 cell ones, literally any of them. But at least we know it's 15, and we've got a 1 here. Ah, that's taken 1 out of here. So the maximum now is 9, 16, 17, 34. Oh yeah, we reduced that to 34 because that was either a 1 or that was a 7. Now, can this be a 3? Has that changed? 9, 12, 13. Oh. Yes, now that's not a 2. This can't be a 3. So we've placed 3. Yeah, the maximum now 9. If that was a 3, 12, 13 plus 9 and 8 is only 30. And that's clearly more. So that is not a 3. Wow, that was a weird effect on that. I didn't realize that was going on. So that's 3 there. 16, 17, 34, still maximum. That hasn't changed much. This isn't any use, is it? I suppose that can't be a 9 and this can't be a 1, but it's a bit good-liffy to mark all those on. But anyway, I've done it. That can't be 5 anymore. Now, maybe I should then... Oh, well, this can't be 28, can it? How obvious is that? And this can't be 25 because there's nowhere... We've only got 3 cell ones left. Why can't I see that? 19 there, 16 here. Now we're cooking. We've got to find a 19, a 16 and a 15 diagonal. Maybe we can limit where they can be. This can still be huge. That could be 19, 16 or 15. Even this can get up to any of those sums, I think. So in fact, and this one could be 15. So, oh, if that couldn't be 15, and it can be by 8 and 6 there. Oh, it could even be 16, yeah. Oh, okay, no, sorry. I was going to say if it couldn't be 15, we're actually achieving something. That's not quite true. Right, but what else have we learnt? Now, this can't be 9 anymore. That takes another 1 off here. Oh, no, that takes 2 off here, because now the maximum here is 15 instead of 17. 15, 16, 25, 32. Ah, so 32 is the maximum. We've now got a 1 looking at that cell. 32 is the number. So this adds up to 32. Now from the maximum, which involves 8 and 7 there, 15, 16, 25, 7 there, is it? They're all maximum. How has that happened? Oh, because we took 2 off the max up here. Yes, 7 there. This is an 8-7 pair now. Wow, how is this happening suddenly? Now that's a sort of funky 8 X-wing. 8s are used, because that's a 7-8 pair and that's an 8-9 pair. 8s in rows 5 and 6 are used up there, so the 8 in row 4 has to be in one of those. It's not here, so 7 is not on that bulb. Now, what have we learnt about the diagonals? We've done the 32 effectively, we've done the 37. This one's second digit can't be 1, 2 or 3. 24, oh yeah, it could still be, no, this can't be a 9, 8 or 7 now, so this can't be 24. 24 is too high, so that must be a 1. 23 is not too high. It's probably too high here. No, 8, 6, 9. No, that can't be 9, 8, 7 or 6. In fact, that has got restricted quite badly. So you can't have 23 here, but I think you can have it here. In fact, that can't be a 9 anymore. I can see a 9 looking at it from there. So we get the 9 here. One of these two is a 9. This is 4, 5, 6 or 7. Can't be 8 or 9 because of that pair. So can this still be 23? Yeah, we can just shove an 8 in there and it's done. Oh, okay. But we've got still a 15, a 16 and a 19 to find. Okay, so where does 19 go? It doesn't go here. It would need 2 9s. 9, 6, it could go here. This is becoming a candidate for all sorts of things. Can this be 19? I suppose with a 9 there, 4, 6. Even this could have an 8, 4. Okay, that wasn't the most profitable way of looking at things. Now, 8 can't be here, so it's got to be in one of those cells. That forms a funky X-wing with those 8s. So there's an 8 up here somewhere. 1, we can place 1 in this box, haven't seen that. So 1 over here is in one of these 2 cells, be nice if it was there. 7, this is a 9-7 pair because of these 7s. That's 2, 4 or 6 as well, so's that, might as well mark it. 8 now is in one of those 2 cells only. 1 and 1, there's a 1 there. There's a 9 in one of these 2, I think. 3, 7, 9, 2. 1 in one of those. There's an 8 in one of these. There's definitely an 8 in one of those. I should have marked that. I saw that a moment ago. Right, now let's keep thinking about these sums. 15, 16 and 19. If that was 23, that's quite a statement. That has to be 23 here, 9, 6, 8. Then where can 19 be? It can still... No, if that's an 8, that's a 9, that's a 7. 4, 7, 4, 8 gets to 19. Bother. Bobbins, 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 bobbins. Oh, what am I missing now then? I've got 19, 16, 15 and something very like, something teen like that still to find. That's a lot of them. Then whatever this is, which could be 14, and this. What's this? Ah, it doesn't have a 7 and a 9 in. Right, 14 is the maximum here. Okay, which is not in those cages. But 12 is the minimum. So it's either 8, 6, 8, 5, 8, 4. It's got to have an 8 in. This must be an 8. So that fixes 9 and 8 here. That fixes 7 and 8 over there. That's a surprise. There's a 7 in one of those cells. This makes 12, 13 or 14. So 4, 5 or 6. Not that helpful. That would be where 12 would be. Also, that would be where 13 would be. No, there couldn't be 13 there because there's a 3 there. Not one of these can be 13, so that's not a 5. The trouble is I just can't pair up these little killer clues with the cages. I want to do more of that, and it's extremely difficult. Oh look, 1, 1. By Sudoku we can place a 1 in this box in the least surprising position of all time. So hard to know. Oh look, that can't be 8 anymore. So we've placed 8 in that box. That's 2, 4 or 6. 8, 8. No, oh, that's on the diagonal. Oh, right. This adds up to more than 15. Ooh. And this can't be 1, 2 or 3. This can't make 23. It's got to be 19, which matches it up to this. Okay, bingo. Done another one. Let's call it orange. This is 12 or 14. Now 14 can go there or there. 12 can only go there, but that could also be 14. This isn't a 4 anymore, so there's a 4 in one of those, and this isn't a 4. This is 12 or 14. We don't know where that goes. Okay, this is 12. Why haven't I marked that off? There has to be a 12. Ah, wake up. Smell the coffee. Right, 12. There we go. It must be up here. That's the only place that can be 12 now. That is helpful, surely. This can't be a 2 anymore. This has to be higher than 4. This pencil marking is beginning to work. Now, this is 12 or 14. It can't be 12 anymore because we can't have another 12. So that's 14. I don't know which of those two cages that is. We've still got a 15 to find. What's this one? 3179286. That's 4 or 5. So that can't be a 4 anymore. Oh, that's a naked single 5. So in fact, this is a 1. So there are only a few things this can add up to. It could be 12, 13, 14 or 15. 14 can be there. 14 or 15 can be there. This is 14. This is 14 or 15. Oh, it's probably 15. What's this? 15 plus... Suppose that could be a 2, making 17 here. Or, of course, this could be 23. No, that would need to be an 8. It can't be an 8 anymore. That must be a 2. 17 is the only possibility in the cages. Perfect. So that is 17. Let's make that dark grey. And that 17 must be here. So we get a 7, which is quite a big shift from 4 possibilities. Now we've got that and that to match with these two, haven't we? Yeah, so that's the 14. Red we haven't used yet. And the other one makes 15, and that must be 915. Yes. And that is all our killer cage matching. Look at that. I feel very pleased with that. That is a brilliant idea. This puzzle is exceptional. So hopefully... Oh no, hang on. Hang on, I've got something wrong, because I've still got this to go. Well, hang on, no, maybe I haven't got anything wrong, because I couldn't get that up to 16. That couldn't get up to 16 either. 15 was the maximum. That couldn't get down to 16. That 16 is going to match up here. Yes, that's fine. That works. That is right. I haven't done anything wrong. It's all good. I hope I didn't make any wrong assumptions because I wasn't seeing that, but I don't think I did. I think we're all right. So this is a 4 to finish the box. Now this has to add up to 16, so that has to be 7 and 8. That's very clear. This is all working. I'm loving it now. Right, 7, 9, 1, 8. Okay, we now it's Sudoku. Now it's just classic, isn't it? Well, I suppose there's thermo virtually. That can't be 7 anymore. So that can't be 6. That has to be 4. 4, 6, and 8. That's where 8 goes. That's where 4 goes. That's where 6 goes. 7 must be here. 1 in box 6 has to be there. Can't do that 3, 5 pair. Let's mark them. That's not a 1 now. 9 has to be here, not here. Haven't resolved that 8 or this 9 pair. These are from 2, 3, and 5. That's not very helpful. Okay, I thought this was going to be easier. This is a weird naked single. It sees every other digit apart from 5. So that's a 6. 7 and 8 can be done in the middle column. 2, 9, and 3 there. They cannot be done. 7, 6 in column 3 is there, and we can finish off the column. That fixes the 5, 3 pair in column 9. Now I can do 4, 5 in, what's happened? In row 6. 6 and 3 are resolved. That fixes this 2, 6 pair, which fixes the other 2, 6 pair. And the bottom 3 rows are complete. This is a right in, 5 there. Yes, I can do 4 and 2, box 1. Oh, brilliant. That's where 6 has to be. 8 in the column must be there. That fixes 9. 2, 9, and 3. That must be 2. It's a naked single. That must be 3. 9, 3, 2. Yes, we're going to finish now. What a brilliant puzzle by Listesh, as we have come to expect from this genius of Sudoku setting. That is a magnificent thing. I love that idea. That's so, not the idea. Well, I do like the idea. I love the execution of it. And these, I mean, even that break-in with the tens digits there and there, that's pretty special in and of itself. The way that just reduced the numbers enough that you could work them out, find the 37. I was probably a little bit slow on some of the bits at the start, but it's a hard idea to get your head around. I've really enjoyed that. So thank you, as always, very much for watching with us, and hope to see you again soon for more Sudoku fun. As it is, bye for now.